Hello, everyone. Thank you very much for joining us today. We're just going to give a couple more minutes for people we've still got some people coming into the webinar room, so please just bear with us for a minute or so, and then we will get this underway. Boy, that was a lot. That minute was a lot longer than I expected it to be. Look, I think we can go ahead and get going. I am David Barnard. I'm the managing director of Gencom Technology. I'm here talking to you today because unfortunately, Donna Kavanaugh, our account manager for Pro Audio, has come down sick and is unable to join the call. But I want to thank you all very much for taking the time to join us and thank Brock in particular for making the time for us. We're going to cover in today's session Sennheiser's latest digital wireless solutions, Spectera and EWDX. Before we get started, I just wanted to mention a bit about process. So everyone's got their cameras and microphones turned off. You are welcome to put questions in the Q&A. In order to keep things moving, we're going to go ahead and do the Brock's talk, and then we'll go through any questions in the Q&A afterwards. So please don't hesitate to drop those in. If you don't see a Q&A button at the top of your window, you might check under the More menu, which has little three dots. We noticed some people with smaller screens weren't seeing the Q&A button. So now I guess, one last thing. If you've got any questions following this, want to get in touch with us for more information, please don't hesitate to reach out to Donna directly, or you can send an email to info@gencom.com, and that will get to all of us. Now, I'd like to introduce Brock Whitton, who is Technical Application Engineer with Sennheiser ANZ. Brock is an audio engineer and acoustic engineer with over a decade of experience and has become known for his ability to translate complex RF and wireless technologies into clear, accessible insights. He joined Sennheiser in 2023, bringing with him a rich background spanning studio production, live mixing, and product development. That includes 3 years at Rode, where he contributed to the development of several new microphones. His academic foundation in acoustics and audio engineering is complemented by a deep passion for music and technology, making him a trusted expert and communicator and a key part of Sennheiser's drive to innovate in the ever-evolving audio landscape. And with that, Brock, I'm going to hand it over to you.
All right. Thank you very much for that introduction. And thank you for the whole team for having me today. All right, I'm just going to load up this and hopefully it all goes smoothly because we know technology loves to work. So hopefully everybody can see a slide right now. So I'm first going to kick this off by wanting to talk about obviously our latest in wireless technology. There's two kind of key products in the cornerstone of this for us, and that is our EWDX or the EWD family. And then we have the new Spectera system, which is the first WMAS system that we have. And that obviously is got a lot more, is a quite a lot different technology to our normal kind of single carrier frequency that we're used to with wireless microphones. So they are two completely different sort of application and products, but they're both at the highest quality. So first off, I had this slide. It says not wireless is created equal. And this is true with our EW digital system. So anybody who knows Sennheiser will know that we've had an Evolution G series, so G1 to 4. which was an analog series, and that went for over extremely long. 1999 to 2018 was the last one, I believe. So that's been a long running family. We introduced the EWD as a sort of as replacing in that evolution family because the digital systems have a lot more advantages than a traditional analog system. So that statement is true. This new digital wireless is far superior than any other wireless we've had before, especially when we get to audio quality. The advances made, especially with the backend and codecs, has been quite amazing. So, and with that, we've put a bunch of work into our Evolution Digital series. So if I take a step back further from that, we actually do have a series of digital products above this called the D9000 and D6000, which is our broadcast level digital system that we released in 2014, which was the D9000. This technology kind of offshoot from that. So we use what we learnt from that technology to create this system. And what we did with that was we managed to actually have sort of a homogenized family here where you get some key features across the whole family. And that includes 134 dB dynamic range. So basically we can capture the entire capsule. Our Sennheiser 835 or 935 are about 140 dB SPL. We're basically capturing the entire microphone's capacity and transmitting it over the air. Also taking away the need for sensitivity on the microphone. You'll see this word, intermodulation free. This is true in with itself. An Evolution digital system will not cause intermods into another Evolution digital system. We have seen in the market as well, we do cause less/none interference into other third-party systems, but as we are Sennheiser, we're saying definitely for our own products, yes, we do not cause intermodulation, which means you can put these microphones in a smaller space right next to each other. So 600 kilohertz, 600 kilohertz spacing, which can be reduced to 300. So you can fit a lot of channels in a TV block. All right, so I spoke about the 134 dB dynamic range. Actually, you should mention that that's 5 times more than most systems in the market, nearly or majority of systems in the market. So a lot of them sit around 120, and it's not just 12 dBs. It's in decibel. It's a power ratio, so it's actually 5 times more input. When I mentioned the sensitivity part, that means your performer on stage or your talent on stage doesn't, if they're speaking and you need to adjust the gain, so actually adjusting the sensitivity of their microphone, so you don't have to go anywhere near the talent. You sit at the receiver and you adjust the gain on the receiver because we are receiving the entire signal. Our intermodulation free, we call it, have a term for it called equidistant spacing. So this is how we space our channels, our frequencies side by side. And that's because we can do it at such a smaller space, and which gives us more higher channel count. This makes it easier for setup. Also with the DX, if you just go into the menu and go auto setup, just like you normally would in most wireless systems, it will find the cleanest frequencies. But it also means that if you are working with a designated RF coordination, when they go to coordinate your systems, it actually is a lot easier for the RF coordinator to go, well, I know all these Sennheiser DX systems can fit in this small amount of space, and that's where I'll allocate them. And just to let you know, with the digital family, we do have an app which is not needed to use. It's a secondary way of operating. It's a Bluetooth, Bluetooth Light, Bluetooth Low Energy. And basically, this just gives you access to the EWD or your portable unit so that you can actually control some parameters or set up from your phone. Very much handy for more of the portable family. So with that, the features across the entire range, which I've already mentioned some, but we also have ultra low latency, so 1.9 millisecond. This is a fantastic number considering digital audio is always going to have latency until we can come up with some crazy new quantum tech to bypass ADCs and DACs. I think this is probably, we're always going to have that little bit of a buffer in the latency figure. So this is a really low number. You'll see here 10 milliwatt fixed RF output. That is actually based, because it's RMS, not peak. It's got to think of it slightly different to an analog system where you'd see 30 to 50 milliwatts. This is actually based on our G4 system, 30 milliwatts from memory. It's actually the same distance you would get and the same amount of energy. It's just because it's RMS versus peak, we can now do it over 10 milliwatts. So we're actually sending less in the air, still for the same amount of distance. So we will state 330 feet or 100 meters, as we always do. That depends on your environment, where you are, the conditions you're in, how much interference it's receiving, what's happening around you. Did you place your wireless system into a rack with a video switcher? All those sorts of things. So that number can vary. And up to 12 hours of battery life, which is with our BA70 battery. You can use AA's as well and get 8 hours, but the 12 hours is for our lithium ion, which gives you a direct countdown as well. On the receiver, you'll see exactly how much battery you have left down to the minute. And from personal experience, it has saved me on a shoot before, where the cameraman forgot to charge his batteries. Mine were in my bag. They had 2 hours, 30 minutes left, and the shoot was 2 hours. We didn't have to worry about wasting time charging batteries. So that was encompassing all of the EWD family. So when we talk about our Evolution digital family, there is EWD and there's EWDX. So EWDX is a more advanced version of our D family, built on the same foundation. So the same codecs, the same latency, the same audio quality. It's just that we've got the additional features that you would expect from a product next size up. So that includes increased range and robustness. So we get a slight bit more out of this in terms of the way that the RF modulation is occurring. It's not too much difference. They are very similar, but there is that slight bit of increasement. The bandwidth changes, and that depends on region. So obviously, with New Zealand, it's less than 88 from memory on the upper frequencies, or maybe both, which means you get more channels because you can fit more channels inside your bandwidth. I should mention that the D family is 56 megahertz bandwidth, and DXO is up to 88, depending on which one you get. We do have 2 channels and 4 channel receivers, whereas the D is only 1 channel. Ethernet control and monitoring, so you can plug these into WSM or our new Soundbase software, and you can allocate frequencies, monitor your environment, etc., etc. And also we have a Dante option. So we have 2 models, a 2-channel and a 4-channel that come in Dante. As we see this kind of sort of transition into more audio over IP world, and we're seeing this is more of a common factor. So that flavor does suit a lot of people. And with that, AES encryption, which is very important. The EU just passed, or passing a bunch of laws at the moment. Well, they've already passed actually, where basically in a couple of years, all audio point-to-point communications will be fully encrypted. So this is already safe for when these changes happen. So this is the 2-channel, 4-channel EWDX with a couple of transmitters, so a microphone, body pack, and I've added the table stand in there because I love the little table stand. What I'll do is actually give us a closer look though at what each of these look like. So this is the 2-channel receiver. So as you can see, quite a simple little package. 2 balanced outputs with 2 unbalanced outputs. This is the standard version with just an Ethernet port for control. We do have an external PSU, so that's a little DC power. The DX can't be powered by our current digital splitter. So there is a splitter that you use with our digital family called the ASA. It works on the 1 channel, but not the 2 and 4 in terms of powering over RF. But there are other solutions, so please throw a question over to Gencom if you have any questions about powering, because there you don't have to just power off little DC plug. One thing is you can do PoE on this unit. That's one way of powering, and there's also a distribution cable. So all the features that we have in the family of the EWD and DX are all packed in here with the 2 channels. With the Dante version, it's very similar, except we've added a Dante primary and secondary port. So same product, just with the option of Dante. This one we'll probably see as more popular, especially going forward. We're seeing Dante kind of be used a bit more in the live world and a bit of in a lot of installs, which is quite good. So when I get to Spectera as well, you'll understand why some of the decisions we've made without audio input, audio I/O that we've made, you can understand a bit more. 4 channels. So this is the 4-channel 1RU receiver. So this does have some differences to the 2-channel. First off, we've got an actual power supply, an IEC. So no more of the DC plugs. No PoE in this one has to be via the PSU. 4 network ports, so these can be used in any way possible, including control, Dante, monitoring, and so you can set up multiple different types of configurations for your Dante via this. So no matter what your preference is, there is a way of running your system. It basically just has carbon copy of your analog outputs, but there is a difference on the RF side, and you notice there's 4 B and C ports. That's because we've actually put inside the EM4 an internal splitter, which means you don't actually need to buy a splitter with this 4-channel rack. You can put up to 4 of these in a row with a cascading cable and with cascading B and C, and you'll get 16 channels via 4 of these. If you want to add more channels, get a splitter, you can put another 4 and expand from there. So with EM4 and our splitter, our EWD splitter, you can get up to 64 channels, which is fantastic. Just off a simple 1-unit splitter. Transmitter wise, we do have a handheld and body pack. In the DX, they come with screens. In our D family, they don't have screens, so there's just a slight difference. Handheld comes in switch or no switch. One of the cool features is we do have e-ink display. So if you turn off your transmitter, it will always display the name on the pack. So when you go to pick it up, you know what you're picking up. If you're using it for the first time, just be wary of this feature, because when I first used it, I thought the microphone was on a couple of times and actually wasn't. It's just like your Kindle e-reader, exactly the same technology. DX does have trim, good for guitar, on the body pack, good for guitar, very important for guitar slash if you're doing any sort of brass with a little clip-on microphone, any higher level SPL, that trim offers a bit more security. And mentioned we got 12-hour runtime, but the body pack also comes in 2 versions, which is a 3-pin, 3.5mm version for lab, or we do have our Limo 3-pin for more high-end applications. So it depends what you're after. One of the cool things about our handheld, works with every current capsule that we have on the market. So Sennheiser and Neumann. We have a huge range of capsules, and they all work across the D series, the 6000 series, and it will be for Spectera as well. So we're not going to make any new capsules. We're using a lot of the same technology. Also, they've got charging contacts. We have a charging solution that you can put them straight into a dock. Real quick, just want to say we do have a table stand for anybody who's interested. A really nifty piece of product. It does come in 3 or 5 pin. So if you want the 5 pin for having the LED features, that's up to you. But a really nifty product, and in a lot of cool applications that we see. I just don't think it's getting enough love, hence why I want to keep talking about it. Great for anything on a stand or speech or conferences, etc., etc. And lastly, of little accessories of this family I want to talk about is the plug-on transmitter. So like a little ENG kit. There is a on-camera receiver as well called the EWDP, and this is kind of in the same family. But this plug-on transmitter, plug into your dynamic microphone or or condenser, because it does have phantom power, and we can transmit to any digital rack of in the EWD series. So either the 2-channel, the 4-channel, the single channel, or our on-camera little one. This can transmit to any as long as it's the same frequency range. It does have onboard recording with an SD card, 32-bit float, or 24-bit, up to you. Handy thing with 32-bit float. If anyone knows this industry, it's a big buzzword. If you overload your capsule, your audio is ruined no matter what. One of the handy things with Sennheiser is we have really high SPL microphones that can handle up to 140, 50 dB. This means in 32-bit float, we're actually most likely going to capture a lot more and have a lot more safety. So the 32-bit float is actually a really good feature to work with our Sennheiser products. It also has a little lav input if you do wish to use a lav, and a high pass filter which is adjustable using the app, which is pretty cool. Some people have used it for measurement mics on PAs at arenas. So some people getting some different use cases out of this product. All right. Now, that was a bit of a spiel on our Evolution Digital family. So that was all our single frequency carrier products. So you tune your frequency, 5, 15, link to link, you've got it. And now we're going to actually shift thinking a bit, because now we're moving on to a product called Spectera. So Spectera is the world's first wideband bidirectional digital wireless ecosystem. That's because we do have one rack unit that can do up to 64 channels of digital wireless audio. And this system is pretty incredibly powerful. And the reason that we can do this, so we just saw a 1RU Evolution Digital that was 4 channels in one rack. So you're thinking, well, 4 channels in one rack, how can you fit 64 in one rack unit? And that's because there's a new technology in the market. And by new technology, I should say this is actually just an encompassing word that the legislation uses for any product that can fit more than one audio channel across the same transmission. So this term is just to encompass anything that comes out that uses anything more than this, what we've been doing beforehand with 200 kilohertz, just picking a frequency, sending it down. Anything more than that now is classed under WMAS. So you will see products come out with this word, WMAS. We were the first on the market first to announce. As it stands, there is only 2 companies down this route, and they're completely different. We actually follow the European standard very closely, which is, it's a very vague kind of standard, which is basically transmissions up to 20 megahertz. You can send up more than 3 channels per megahertz. There's a bunch of different things they kind of say, and be bidirectional. So we've really kind of pioneered this. I should mention that we did pioneer this. This was a Sennheiser-led mission from 2012 onwards. European legislation changed in 2017, and it's taken years and years of work to get global legislation across the line. New Zealand, December 18th last year, I'm pretty sure it kicked over for the new WMAS legislation. Australia is still indoors only, and our outdoor legislation kicks in no later than September 30th. So this was a big change. The FCC was only in February. So Sennheiser and other companies worked hard to do this. Originally, it was a joint collaboration when it first started back in 2012, because we're seeing the need for more channels in smaller space, which is a bit of a statement here because the system is running on a bigger bandwidth. But it's a shift in thinking, because now we are actually, even though we are taking out more spectrum, we are fitting more channels inside that spectrum. So we are technically saving spectrum. And that's the key here, because going down the line, and I'm talking future, 5-10 years, when spectrum potentially starts to be gobbled up, the system is prepared for that, and we can fit more channels in. All right, so Spectera as a product. Oh, sorry, my presentation's frozen, so give me 1 second. For some reason, it's stuck. All right, cool. That's loaded back. All right, Spectera. So the future of Pro Audio Wireless. This is the future, although it is not here to replace our current systems. So all that I just spoke about with our Evolution Digital Wireless, it's not replacing that. It's to live side by side. Because if you only need 2 channels, this system is overkill. An Evolution Digital system, 2 to 4 channels, oh, that's significantly a better solution. You are being way more efficient with your spectrum. Anything that is scalable, maybe you do need 4 today, but 16 tomorrow, and then 32 a week later, this system still is perfect for that. So how does that look? So we have a bidirectional body pack. This body pack is very similar size to our Evolution Digital series, actually. Even has the same e-ink display, except one key difference. We have a headphone jack port, and we have a 3-pin LEMO mic line input. This means that you can run your ears and your microphone at the exact same time. And this is exactly how the system is meant to be used. We're saving not only spectrum, but we're saving architecture. If you're going live to air on a broadcast, instead of 2 packs, we're now down to 1 pack. This is exactly what we see. We've been using it in Australia now on broadcast shows since January. And the talent have noted how much they prefer to only put 1 pack on, especially now these days. A lot of talent have to put the packs on themselves because the way the world is going, and budgets. 2 other cool features of this product. So we have an endless rotary encoder. So it's a really nice feeling encoder. It doesn't have an on and off, it's just an endless. And we also have an antenna that can be taken off. So a little SMA port. We only do have the 1 variant. So there's only 1 antenna. There's no need to buy a different variant. 1 antenna covers all. In this little picture, you'll see a little tiny one. This is the generic, our Sennheiser slides, which have both variants, which is UHF and 1G4. Australia and New Zealand, only UHF. For now, especially. So there's only the 1 variant. When you buy this, it just comes as a UHF system. It works with the same batteries that we use on our digital wireless Evolution series, the BA70. This cannot use AA's. It takes a bit too much juice, especially when we talk about the output power and the potential in the future when we have better batteries for unlocking 100 milliwatts in the pack. It just gets a bit too much for a AA. You would drain your battery pretty quickly. So we use the battery from our digital system, and what that means is that we didn't have to create any new battery infrastructure. So the same chargers that we've been using for the last 5 years on our digital Evolution is exactly what we use for this system. So if you are a digital EWDX user and you move to Spectera, it's quite an easy adjustment. If you have both in your inventory, you can use the same charges in your inventory. So a bit of a sustainability key point for Sennheiser here. I want to give you a kind of a bit of a thing here about what we say, like the new reality is of what Spectera can do. And this is a real world example of using 16 D6000 channels with a splitter, two antennas because diversity system. We have their 4 2000 series IMs. So let's go 8 stereo or 16 mono for this example with your antenna, your combiner, and all the packs required to run this system. Actually, oh, sorry, 8. We'll go 8 stereo because that's the 8 packs on the picture. This is what you need to run this system. This is what you would see in a normal average scenario for this, maybe at a international touring act, potentially. And this is in a huge rack. Actually, this is probably over 2 racks because it's quite a lot of equipment. We can condense that down in Spectera down to 1 base station, 1 antenna, laptop or iPad or whatever to run the web interface or software, and transceiving body packs or a few handhelds. As you see, that is a lot less equipment. That means if you're touring, that's a lot less gear to take. If you're installing, this is an easy unit to place. Here in down here in Melbourne, or in Melbourne, NEP, the Fox Footy, AFL, this lives in the server room, hidden away. They don't have to worry about it. They just put it in the server room and happy, good, we're good to go. So when you start to see larger scale system like this, not only do you see equipment, but you'll start to see a price adjustment, which obviously is a talk for a different time. But the more you scale up, the more the price becomes very valuable because you're not only getting an ear system or a mic system, you're getting transceiving, you're getting both ears and mics. So it's a really cool example, and you may be wondering why there's only 1 antenna. And there's 2 for the normal systems because every digital wire system up until this point in everything we use uses 2 antennas, an A and a B for diversity. Spectera only needs 1. And the reason for that is because I mentioned before, we have WMAS. So WMAS is actually the obviously the big name for just multi-channels, but what we're doing with WMAS is we're transmitting 6 to 8 megahertz blocks. So it's either one. You transmit your big block of spectrum, and inside that block is where we're shoving all of our information. So in a normal system, if you see this flashing little graph here, on the left, it's 16 channels of bars of your individual frequency normal EWD system. Basically, when we see here with the 2 antennas, we have phase issues because when you move around a room with multipath, you're going to have the wave collapse in on itself and cause a null. Hence why we use diversity, because if there is one goes down, another picks up. If you get unlucky and both have an issue, you lose signal briefly until you move. With the Spectera system using a 6 meg block, we're not using frequencies as we normally would, single frequency. We're transmitting on up to 200 subcarriers at once. So if a frequency even was to have something happen, like an interfering signal, we do not lose signal. So what this means is that as well, is that because we're transmitting on all those frequencies and those phase notches occur on selective frequencies based on waves, it also means that diversity is no longer needed. So we go from 2 antennas to 1. So a 6 meg block is 30 times greater diversity than a traditional system. Last week, we tested this in a 20,000 seat arena in Sydney. I am a big proponent of using 2 antennas for redundancy. So one for just to have one as a backup and coverage. NEP said, nope, we're using 1 because it covered the entire arena bowl with 1 antenna, and they ran live to air, no issues. So it's a pretty incredible system. And for someone like them, that becomes a lot more appealing when there is less equipment to set up. Uh, so, oh, and they're doing transmission and receiving all of that one antenna, which is pretty crazy. So the reason that we can do bidirectional, because inside that 6 meg block, we're using more akin to your mobile phone or Wi-Fi. There are a bunch of different um, things happening in the modulation there. So one of them is TDMA. We then have TDD, which is time division duplex for sending, transmitting, or receiving. And then we use OFDM, chopping into hundreds or 200 subcarriers plus for sending the information. So we're not reinventing the wheel by creating a new technology. What we did was we took existing technologies and did it our own way. And the reason we had to do it our own way was important. When I get to the figures next about latency, etc., we couldn't just use a Wi-Fi signal, and we couldn't just use similar to your phone. We did have to do something different. Graph on the right, by the way, is an example of single frequency carriers at 50 milliwatts. So a system that can do 50 milliwatt carrier versus the blocks underneath it are actually the Spectera system. It's exaggerated, of course, but what we're trying to say here is that our power output is spread across the entire spectrum. It's not via one single frequency. We coined a term for this called RF politeness, because we are being polite to everybody in the spectrum who are around us, which is actually very useful for, let's say, a festival, a main stage. Stage 1, 2 can run on a 6 meg block. Stage 3 over there can run on the other side of the festival grounds, can run the same 6 megs, and they will not interfere. Also, if your pack is on main stage, it will not cross into the other stage's 6 megs. You can't walk into that 6 megs because they are fully linked to the base station. So you can put the same frequency in smaller spaces and reuse that space, which means we actually are not just polite, but we're saving spectrum again. Theatre, New York, probably theatre would love this. Well, they do love it when the mini body pack comes out, because all the buildings are next to each other. They can reuse the same frequencies at a lower milliwatt output. So quite an incredible little system. And when I mentioned before about latency figures, we had to rewrite or redo things our own way, because we have gotten the IEM setting on a stereo IEM down to 0.7 milliseconds. So that is the quickest latency figure inside of our system, because we have 11 different audio modes spanning across mic and IEM or IFB. IEM IFB has stereo mono, mic just mono. In these 11 modes, 9 of them fall under 3 milliseconds, or fall under 2.7 milliseconds. Only 2 modes fall outside that, and they use our the Opus codec. Opus codec. So just for transmitting, it's not really, it's like a lower quality, but it's still a good quality signal. We see 9.9 milliseconds and 15 for those 2 modes. Potentially they're more of a comms mode or a back channel or a comm mode talking to producer, etc. So you can save more space with those modes. But most of our 9 of the 11 are falling under sub 3 milliseconds. The microphone, the lowest we get down is to 1 millisecond. So these are quite quick figures, and this is system latency, not round trip latency. Obviously, you're going to have to account for going for your mic into out of Spectera into a mixing desk, into your plugins on the desk, into etc. and blah blah blah. So the reason we have those low figures is to help with our round trip latency, and they were all the figures were considered and created with the idea of understanding the round trip. So there's 3 different codecs in those modes. I've mentioned Opus for those 2 modes with the high latency. CDAC, which is our broadcast quality codec from D6 and D9000. It's the same codec. It is improved upon. So we've had some slight adjustments. So think of it as CDAC plus. And we have also PCM, fully uncompressed audio. So 96 kilohertz over the air uncompressed audio, which is pretty amazing. And the reason that we have 11 different modes is because we can't transmit and receive everything all at once. And what I mean that is that we have kind of 5 key factors: latency, channels, quality, runtime, and range. If you want more of something, you've got to take away from something else. My boss uses the term no free lunch. You can't have everything. So we've got to pick and choose what you want. And this is how the modes were created. We said, if you want the best latency, what is a sacrifice? So what would that sacrifice be? So I did this little visual example. If I want to drag that the top of the shape here, if I want to drag that up for better latency, what's going to happen? Well, it's going to drag in the channels. So I've lost how many channels I can use. And this is actually also to do with how much time slots we use inside of our spectrum. So the better latency you want, or the more things you want of that, the more time slots we use, the less RF spectrum we have to use. So do the same thing. We want better range. We're going to lose battery runtime. So like I said, no free lunch. Should mention when we talk about runtime, on a standard bidirectional live mode, which is our D6 kind of 1000 mic mode with an ear in, you get up to 5 hours. So it's actually 4.5 to 6 hours is the stated battery runtime. We're seeing more 5.5 in real life, and unidirectional. So if you're only transmitting or only receiving, you can get 5 to 7. So it's still pretty decent in terms of battery runtime. We are working on a higher capacity battery, which will improve these runtimes significantly, as well as allow more power output. I want to talk about the antenna real quick. Like I said, you can run this show off 1 antenna if you wish. Still think 2 is probably better. But with the antenna here, you're going to notice something that's a bit different to any other antenna, is with this big box on the side of it. This is because it's a digital antenna. So being a digital antenna, we have ditched coaxial cable. No more cable loss, no more calculating how much dB you need to make up because you've ran 20 meters of RG8 or some crazy thing like that. We are doing all of our RF conversion on the antenna. So what we're actually doing is sending out a signal over either Cat5e and above, preferably Cat6, but Cat5e and above, an Ethercon, or with a fiber converter, you can go a fiber and go up to 3.8 kilometers if you wish. So on your Cat cables, 100 meters, or your Ethercon, you can go through patch points. This is point to point, layer 1. We can't go through a switch. A switch that's maybe in the future at some point, but for now, and with the new antenna or something, but for this one, it's layer 1, point to point. You can go through patch points. That's fine. But the antenna has to talk to the base station. So 100 meters with Cat cable in Ithacon, nearly 4 kilometers with fiber. We do have an approved fiber list starting. There's 1 or 2 on that list in the manual. More will come because it's now out in the real world, and we're testing with more fiber options. We tested with one on the last Thursday that was, can't remember the name of it, and it worked perfect. So this list of kind of fiber converters will grow once we get more use cases, but we do already have an approved list. So if anybody does have a need for a very long distance run cable runs, come talk to us. We've got options for fiber. The antenna is PoE powered. So if you are looking at fiber, it needs to have a PoE injector, which makes us why we have in a list, because we have to pick and choose the right ones. This antenna does the 6 or 8 meg carrier system um, across the antenna at all times. And in a second, we're going to talk about some of the features of this antenna once you plug into the base station. But the last thing I want to mention is the IP54 protection and interference management, because that's on the packs as well. Each antenna and each pack. What happens is if you run a 6 meg block and someone puts in an interfering signal into your 6 meg block, the antenna and/or slash pack has the ability to notch that frequency out of its system. We can do this up to 2 at the moment before any signal degradation. So if you're running an event, a coordinated event, and someone rocks up an ENG, which it's always news, it's always ENG, turns on their microphone without thinking because they think they can do whatever they want, you'll see interference pop up into the software, to your web GUI. From there, you can actually see that it's at this antenna or this pack, and you can kind of go locate where that is. But you can get up to 2 without issues. More than that, we will start to see signal degradation. And now I want to talk about the base station. So this is the big computer that runs everything. So it's quite simple. Front panel, all we have headphone monitoring with a simple headphone knob. So you can listen in to any channel, including transmit and receive. So it doesn't matter what line you want to listen to, it will let you choose. Has a airflow filter on the front, which is changeable and cleanable, because this is a big computer and it's doing 64 channels of audio potentially. It needs that kind of airflow. You'll see there's only one control knob next to the OLED screen. So this is not designed to be for you to set up an entire show. It's a monitoring station, so you can monitor audio or / your network or licensing or any of those things. It is not meant for configuring. You don't want to be sitting at this piece of hardware, sitting up 64 channels of audio. So we've taken that kind of away. And it's now moved to a web interface and/or / software called Link Desk. On the back, you will see we have redundant PSUs. Very important. We also have 4 antenna ports. So these 4 antenna ports can be used in multitude of different ways. You can have one plugged in to run your whole show. Plug in a second antenna, I have redundancy. Plug a third, I can pick one just for scanning. Like a fourth, you can do a few different things, but one of the key features I haven't mentioned is this system not only runs one 6 or 8 meg block, it can run 2 at the same time. So one antenna can be 5, 10 to 5, 16. Another antenna can do 530 to 536, which gives you, so you are taking up more spectrum, but it allows you to fit more channels in, because when I said before, when you're picking better latency and better range, you're going to lose things like losing channels. You're using more time slots, you can't fit as much channels in. So on our stereo IEM mode, you actually, at the highest quality, 0.7 milliseconds latency, you actually use 25% of your RF capacity. So you can actually get 4 stereo IEMs out of a 6 meg block. If you were needing this, let's say a band situation, they needed that 0.7 milliseconds latency at that mode, and use that 6 meg for their ears, you can then run another 6 megs with another antenna for everything else, and that's fine. So it's about, we call it kind of resource management, using up the RF. That example I showed before with the 16D D6000 and 8 stereos, that is a real world example of using the modes. You can fit that many channels on a 6 meg block. Hence why we use that graph as an example. And I will talk about in a second, I'll show you some actual examples of those antennas setups and what that looks like. We have word clock and network control. Network control is important because the way to operate this system is via our software, which it's free. It's called Link Desk, or just type in the IP address onto your into your Google Chrome, your Edge, whatever. Log in to your web interface, and you can control everything from a simple web interface. This does offer remote control access then. And in the future, we're going to offer more accessibility in terms of user rights, in terms of who can do what, who can look at, or you can edit, et cetera, to offer more remote control. So you could actually send this out with an A2 tech who doesn't really, who knows what they're doing, but not competent, and it's already been set up. You can actually just have them plug everything in, set it up, just monitor, and then you from home base can actually control everything, which is quite for anyone in broadcast or anything similar. That's quite an amazing feature. So that network port, quite important. We do have a cascade port, and it says in brackets future expansion. This will come out some point in a year or so time, maybe roughly. Cascade port means that you can go from 64 channels, the 32 by 32, to 64 by 64. The reason we use these 32 by 32 64 channels of audio is because there's the way the chips are designed in the system means we can only get 64 channels of physical audio in the base station. To do more, you need another base station. One advantage of cascading means you get more antennas. In one kind of 6 meg block, you can expand from 4 to 8 antennas just by cascading a system, which means you can multi-zone quite heavily. But that's a future expansion. We can't really talk too much to that at the moment. It is Dante. So this is why I mentioned Dante earlier, is because the system runs inherently is a Dante system. I will openly talk to you about, we are working on an AES ST2110 version for early next year using our merging Z-Man chip. It's currently in testing. For how that looks at the moment, we can't really say, but potentially there will be a separate version which is just ST2110 AES. Different flavors, obviously. But we also do have 2 optional slots. These optional slots, at the moment, there's 2 MADI cards, optical and coax. You don't have to get these on purchase. If you do need MADI, you just put it into your purchase, and they just simply screw out and plug in. Simple little cards. And in the future, we'll see obviously more expansion on those cards. So I want to show you how those antenna setups could look in the real world. Here is a single normal EW Evolution wireless digital setup, diversity antennas, A and B. So green, yellow, A, B, just like your normal would on stage. With Spectera, just with one antenna, we can do that entire system just with one. And we're all good. So 30 times greater diversity. Add a second antenna on the same block of spectrum, we get coverage and/or / redundancy. If I want to, oh, someone's lost slides. It's not good.
It's David here. I'm still seeing them. So
okay, cool.
You might want to, if you've lost them, you might want to try and disconnect and reconnect. We'll let you right back in.
Yeah. Oh, we're coming right to the end as well, so it should be okay. So if you have 2 antennas, but you want to use 2 6 meg blocks, so 6 megs, 510 to 516, 530 to whatever, that's as simple as one there, and you're running 2 separate spectrums for whatever purposes. That's fine. Let's say in that example of the first one, running redundant zone, I can add a 3rd antenna to the bottom left, And that third antenna can be used for continuous scanning. It's 2 or 3 second refresh rate at the moment. And with this, you can monitor your environment. And going forward, there'll be more features, obviously, for improving how we monitor the environment, including and having a backup 6 megs if you need to switch. Because remember, we're not frequency hopping if something happens, because we're using a big chunk of frequency. We're first going to notch out the interfering frequency. To shift your spectrum, you have to shift an entire 6 megs. It's a couple of seconds of downtime because you've got to communicate to all packs that they're switching. One advantage I should have mentioned is all communication is done via UHF. There is no Wi-Fi. There's no 2.4 backlink. It is all over UHF, which means you can pack communicate from 100 meters away if you wish. Even firmware update from 100 meters away. It's quite amazing. As long as it has a UHF connection. Just going to show one example of using 4 antennas on the same 6 megs. This is just a little funny one I add in. You get 120 times diversity. So just a fun one to add in because it's quite a fancy word. Dysiakics. I'm not going to say the word anymore. I'm just going to end on real quick 2 other ways that you can use the antenna system. Put an antenna up. Use a racetrack here just as an example, like a pit lane or something. Just like you would with a speaker delay. You could put another one down 100 meters and get coverage because you can just extend the coverage. That's one way to think about how you can use the antennas. And in the exact similar way, take that example, but put it into a building. And here I've got 4 rooms. 1, 2, 3, 4. I now have a multi-zone system. This multi-zone system is doing mics and IEMs. So remember that there's not really an option for multi-zoning IEMs in the market. So this is one of the first inherent systems that is doing multi-zone IEMs, but it's doing both at the same time. I do also want to end on just going to have a holding slide here. I just want to end on and talk about what's coming. I can't show pictures. Just so everybody knows, we are doing a handheld. The handheld is due next year. It's currently slated for middle next year. Yeah, sorry, mid next year. We know how important it is, so they've been working very hard to work on the handheld. As soon as we get more information, obviously we can release it, and more information about it. But we do know how important a handheld is. So that is 100% coming. It will work with all of our Sennheiser Neumann capsules, just as you would expect. And just so everybody knows, after that, we will also be doing a mini body pack for, say, theatre. Little similar to our SK6212. The mini body pack potentially will have 2 transmit lines for redundant lavs, but that one we're still yet to see final design. But that actually won't be too long after the handheld. So just to keep everybody in the loop, we are definitely have a handheld and a mini body pack in the making. There is a long list of requests for this product. Over the next 18 months, a bunch of these requests will come out for software-wise or firmware-wise. And we'll see a lot more things for touring. So engineer mode, of course, be added. When the handheld comes out, there'll be command mode. We're going to have features based for theatre world, broadcast, touring, etc., etc. All these will be coming over the next 18 months, including reliability updates, obviously, and any improvements that can be made. But these are all open and free to actually look at. If you want everything I just mentioned, we're openly saying because we are being very open on the development of this. We do have a Sennheiser. If you log into the Sennheiser website, make an account, there's like a little Sennheiser, my Sennheiser website, and we have a Spectera roadmap, and you can actually include your own features that you wish to add. You want to add a feature? Yep, cool. It gets sent. Development look at it. They actually say, oh, that's a great idea. We'll add that in. It's approved. Or, hey, we've already received 20 requests for this. Let's shift and make that more important. Let's shift it down the timeline. And development also give feedback on those cards. So we are being openly to the public. We are being very transparent about our development of this system and about what's coming. So any questions you can, as much as I can answer, I will answer about what is to come in the next 18 months. But it's also all publicly available via the website. Okay, look at that, bang on time for that.
Well done.
Do you want
Brock,
me to stop sharing that screen and we
thank
can?
you.
Okay.
Thank you very much for that. Now, so far, we don't have anybody who's asked any questions in the Q&A. Does anyone have any questions they'd like to ask of Brock? All right, no questions. It was a detailed session, so a lot of good information in there. So, yeah, thank you very much, Brock, for that. Thank you very much, everyone, for joining. And once again, if you've got any questions or any follow-up, you need a quote, anything like that, please feel free either to get in touch with Donna Kavanaugh, our account manager for Pro Audio, or you can send an email to info@gencom.com, and we will all see it and make sure we address it.
Yep. So, you know, this system is, oh, if you can see it, if you can see my screen, it is quite an amazing little system. Also, it's a little cap here for my mic port. I've been doing a lot of field testing with this, so I can just add a little bit extra just to why people are online. Doing a lot of field testing with this, and it's far surpassing anything that I expected, including, so, you know, in Australia, outdoor is, we're not technically allowed to use it outdoors, but a friend of a friend did some outdoor testing, let's just say. And, you know, we have now seen 2 antennas cover the entire field of an 83,000 seat stadium, which is on the same 6 meg block. Quite impressive. We've seen it been doing a few other similar things here and there. But all my field testing, I get worried and I always go, we should really be doing this, and this. And, you know, I work with NEP a lot and they just keep putting things to air. So, because it works fantastic. And just for globally, just so you know, NEP in the Miami PGA headquarters, live to air since December. A bunch of touring bands have been using it for years, for a while now as well. Hans Zimmer's Experience show in Europe used the system. Chick loved the system. They were field test for us. They asked for it back because they loved it. And basically, we're just doing as much field testing as we can. Well, the product is available, obviously, now. But we're seeing the real world testing come through, and everything is being actually incredible. So, just personally, as someone who's been testing it, it's been fast passing everything I could ever imagine. I was there in 2023. I went to Germany and saw this system in its before it was obviously finalized, and to see that to go from there to here, it's just been quite an amazing journey. So, quite a cool piece of gear.
That's fantastic, Brock. Thank you very much. Right. Okay. Well, we've still not had. Oh, I see somebody's in the chat. That was just a reminder to pop questions in the Q&A sections. I've also been reminded that this will be made available on demand. It'll automatically be sent to everyone who registered. So if you need to go back and refer to anything, or somebody who missed it, it will be available on demand.
So someone has asked the weight of the body pack, which is a very good question. So off the top of my head, I'll have to look this up, but I can tell you the weight of the base station because I've memorized that, which is 6.3 kilos. So it is slightly heavier than the one I use system, than another system. Still flyable, which is something, you know, when I first had this system in January, I put this in a 3RU gator case with my handhelds and antenna, and I put it in the overhead compartment of an airplane, which is pretty amazing. But the weight of the pack, it's not there. I'll have to have a look at the tech specs here, but it's quite light. It's lighter than as light as our DX pack, actually. So not heavy at all. Extremely It's not as light as, say, a mini body pack, obviously. But for the exact figure, I can't see on the spec sheet. So sorry about that. We'll have to look up later.
Okay. Right. Well, thank you very, very much, Brock. And thank you everyone who has attended. We really appreciate you all taking the time out.
Thank you.
Take care, everyone. New question, last minute. Can you have two receivers say, oops, why is it not showing up on my screen? I saw it pop up, but I didn't see.
It's in the chat. Can you have two receivers say cam as PA? So what do you mean by that, Brian?
Hold on a second. Let me, I think we can, Amer, can we unmute him so he can clarify?
Yes, I think we can. Give me 1 second.
Camera and PA system. You have two receivers say camera and PA system.
Okay, so if you're transmitting to something, yes. So similar to you would with an IEM, traditional IEM system, where you would just tune the same frequency. You can group packs on the same signal path, and they will receive identical signals, just like you would with an IEM. You can do up to 128, whereas with our traditional analog IEM, that's unlimited. But with this system, 128 can be linked to the base station, all running the same mix. So if you do need to send something to a camera or something to from a camera from a PA to somewhere else, that's possible. If not, if you need to, there is also the internal, sorry, not internal routing, but once you're routed to your Dante, you can just obviously route through there to do whatever you need via sharing mixes. But receiving mix definitely can share a mix.
Okay. All right. Last call for anyone else. Any questions? No. Okay. Brock, thank you very much. Everyone, thank you very much for joining. Have a great rest of your day.
That's good. See everybody.
Bye.